This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy. We go deep and lightly surface the big ideas. Welcome to your deep dive. Today, we're going deep on this paper from the Journal of Virology, and, well, it's a doozy.
Yeah, a bit of a head scratcher, right?
Yeah.
You'd think our immune systems, would be all over this when a virus shows up.
Yeah, you'd think so. But this research is saying, maybe not.
Yeah, suggesting the virus might be like hitting the snooze button on our defenses.
Okay, so we've got this paper. It's dense. It's all about how the virus is like messing with our immune system's ability to fight back. Where do we even start?
Well, the key here is this thing called the interferon pathway.
Okay.
Think of it as your body's like burglar alarm, when a virus breaks in.
Right.
Like, let's say you have a cold or the flu and you're feeling all achy and feverish. That's your interferon pathway kicking in. It's like sounding the alarm and sending out the signal to fight off those invaders.
So instead of like barging in this virus, is like cutting the wires to the alarm first?
Exactly. That's a good way to put it.
Sneaky.
Yeah, the research actually found that the SARS-CoV-2 spike protein.
The one everyone's heard of.
Yeah, that one. It's actively suppressing the interferon pathway. It's like giving the virus a head start, before our bodies can even realize what's going on.
Hold on, back up a sec. Why is this interferon thing so important? Like, what does it actually do?
Well, interferon is one of your body's first responders to a viral infection.
Okay.
It's like the 911 operator of your immune system, sending out the alerts to all the different defenses and getting them ready to fight.
So by suppressing interferon, the virus is basically delaying the cavalry.
Exactly. Making it much harder for your body to mount a strong defense right away, in those early stages.
So it's not just about the virus, like, replicating. It's about actively weakening our defenses right from the start.
Yeah, precisely. And this is where it gets really interesting.
Okay.
Because the research found that this whole suppression process is mainly driven by a specific part of the spike protein.
Like a certain section of it?
Yeah, it's called the S2 subunit.
Okay.
And get this, the subunit is very similar across different coronaviruses.
So this isn't just like a SARS-CoV-2 thing. Other coronaviruses are using the same playbook.
It seems like it. This suggests that it's not just some random trick. It's probably a common tactic that lots of coronaviruses use to weaken our immune systems.
Wow. Okay, so how does this S2 subunit actually work? It's not like physically fighting our immune cells.
No, it's more like sabotage than a fist fight.
Okay.
The S2 subunit disrupts this crucial part of the interferon pathway called the ISGF3 complex.
ISGF3?
Yeah, it's a mouthful. You can think of this complex like a team of superheroes.
Gotcha.
Each with their own special powers. And when they come together, they activate the production of hundreds of antiviral proteins.
Oh, so it's like the Avengers assembling, ready to fight off the invasion.
Yeah, exactly. But then the virus throws a wrench in the works.
Uh-oh.
The S2 subunit prevents the ISGF3 complex from forming correctly.
So it's like breaking up the team before they can assemble.
Yeah. It does this by binding to one of the key proteins on the team, preventing it from linking up with the others.
So it's like taking out one of the Avengers and keeping them from joining the fight.
Exactly. And this has big consequences. Without a strong interferon response, your immune system isn't as equipped to deal with the virus.
Meaning
You could be sick for longer, or your symptoms might be more intense.
But isn't the immune system pretty smart? Are there other ways it could compensate for this suppression?
Well, the immune system is incredibly complex, right? It has multiple layers of defense.
Right.
So even if one pathway is disrupted, there are often backup mechanisms that can step in.
Oh, okay.
But this interferon response, this is a crucial early warning system. Suppressing it gives the virus a big advantage right from the start.
Okay, so it's not the only player, but definitely a critical one, especially in those early stages.
Yeah, that's a great way to put it. And this research helps us understand just how vital that early response is, especially when it comes to coronaviruses.
All right, so we've got this tiny protein causing a big headache for our immune systems.
Yeah, it's a tricky one.
Now, what does all this mean in the real world? We'll be back in a flash to unpack how this research could change how we think about vaccines and immunity.
Thank you to everyone who has left such positive reviews on our podcast episodes. It helps to make the podcast visible to so many more people. We read them all. Back to Heliox, where evidence meets empathy. And we're back digging deeper into how these coronaviruses, those sneaky little things, mess with our immune systems.
So we've been talking about this whole tactic the spike protein uses, suppressing our interferon response. But what does all this mean for us, out here in the real world? Why should we care about what this tiny protein is doing?
Yeah, that's the million-dollar question, right? We got to connect the dots from the lab to our everyday lives.
Exactly.
Well, one thing this research might help explain is why those booster shots are so important.
Okay.
You see, if the spike protein that's used in some vaccines is also suppressing the interferon response, even if it's just temporary, it could mean our immune system isn't getting the best training possible.
So even though vaccines are giving our immune system a sparring partner to practice on the virus is kind of like cheating by messing with the referee.
Huh. Yeah, that's a great way to think about it. And this brings up another really important question for future vaccines.
Which is?
Can we, outsmart the virus? Can we design vaccines that trigger a strong immune response without also triggering this interferon suppression?
That sounds like a challenge.
It is. It's a tough one. But researchers are working on it. There are a bunch of different approaches being explored.
Like what?
Well, some scientists are trying to modify the spike protein that's used in the vaccines.
Okay.
Tweaking it so it can still train the immune system, but without setting off that interferon suppression.
So making it a little less sneaky.
Exactly. And others are looking at totally different types of vaccines, like those mRNA vaccines you've probably heard of.
Right.
Those might stimulate the immune system in a whole new way.
It's like we're trying to create a vaccine that's always one step ahead of the virus, blocking its moves before it can even make them. But let me ask you this. If this interferon suppression is happening inside our bodies, are there any noticeable effects? Would we feel any different?
That's a tough question, and to be honest, we need more research to say for sure. The effects of interferon suppression can be different for everyone, and it depends on, how severe the infection is.
Okay.
But generally speaking, a weaker interferon response could mean you're sick for longer or your symptoms are more intense.
So it's not like we'd suddenly feel our immune system powering down or anything?
No, not like that.
Yeah.
It's more subtle. But over time, that suppressed interferon response could contribute to a bunch of different symptoms, from feeling tired and achy to, in some cases, developing more serious complications.
So it's all about how well your body can handle the virus in the long run.
Exactly. It's not the only factor, but it definitely plays a role in how our bodies deal with the virus over time. But it's also important to remember that our immune systems are incredibly complex.
Oh, yeah, for sure.
There are lots of moving parts, and interferon is just one piece of the puzzle.
Right. So there are other defenses that can step in, even if interferon is suppressed.
Exactly. It's like having a backup generator when the power goes out.
So it's not game over if the interferon pathway takes a hit.
Not at all. There are other players on the field ready to step up. And this research might even help us figure out ways to boost those backup systems, making our immune response even stronger.
So even though this virus can be pretty tricky, our bodies are still pretty amazing at fighting back.
Absolutely. I think this whole deep dive just shows how incredible our immune systems are. They're constantly learning and adapting, even when they're facing challenges like this interferon suppression. This research gives us a glimpse into that process, and it helps us figure out how we can best support our immune systems in this fight.
So it's even though this virus is coming at us with, some serious moves, our bodies are still ready to rumble.
Yeah, that's a great point. Our immune systems are always learning and adapting. And even when they're up against something like this interferon suppression, this research really gives us a closer look at how that works.
Yeah, it helps us figure out how we can help our bodies fight back.
Exactly. And we were talking about those backup systems before. Our immune systems are amazing. They have these layers of defense. So even if one pathway gets blocked, there are others that can jump in and take over.
So even if the virus is cutting off one line of communication, there are other ways for our immune cells to talk to each other and, coordinate the defense.
Right. It's like having this whole network of walkie-talkies.
I like that.
And, this research could even help us find ways to strengthen those backup channels, make our immune response even stronger.
I hope so. So after this deep dive, what's the one thing you want listeners to walk away with? What should they be thinking about when it comes to this whole virus and immune system thing?
I think the biggest takeaway is that knowledge is power. The more we understand about how these viruses work and how our immune systems respond, the better we can protect ourselves and the people around us.
It's about understanding it and then, doing something about it. What can we do with this knowledge?
Well, this research is a call to action. It shows us that we need to support scientific research and stay curious about the world. And, we need to support policies that make public health a priority.
For sure. And it reminds us how important it is to stay up to date on vaccines and boosters.
Absolutely. Vaccines are still our best defense against these viruses, even if they're not perfect. And who knows, maybe this research will lead to even better vaccines. Ones that can outsmart those viral tricks.
Now, that would be amazing. So this research is like opening up all these possibilities for how we fight back. It's like we're finally starting to understand the rules of the game.
Exactly. This deep dive has shown us that even these tiny things, like a single protein, can have a huge impact on our health. It reminds us that there's still so much to learn about viruses and immunity.
Well, I think we've all learned a lot today about how these viruses work and how our immune systems fight back. It's a constant battle, but we're learning more every day about how to stay one step ahead.
Yeah, we are. And there's still so much more to discover. This is just the beginning of the story.
That's your deep dive for today. Until next time, stay curious.